In this video, we're going to pick up with where we left on the last video, which was work. So we are talking about energy and the different forms of energy. One of the ways that a chemical reaction or a chemical process can transfer energy is through work. The other way is through heat. So energy is also the capacity to produce heat. Heat, which is symbolized with a lowercase q, is the transfer of energy by thermal interactions. It is a process that occurs spontaneously whenever two objects at different temperature come into contact with each other. Energy flows from the object at higher temperature to the object at lower temperature. Always. It will always go from higher temperature to lower temperature. Whenever they reach the same temperature, that is called thermal equilibrium, and heat transfer stops at that point. Consider two drinks: a warm cup of hot chocolate and a cold glass of iced tea. When you hold a warm drink, your hands are at a lower temperature than the drink, so heat will move from the hot chocolate into your hands, simultaneously cooling the drink and heating your hands. When you hold iced tea or a cold beverage, however, it feels cold because heat is leaving your hand and going into the drink. If you held either object for a long enough time, they would both eventually come to the same temperature as your body, so approximately 98 degrees Fahrenheit. Heat is related to, but not the same thing as temperature. And this is a really confusing concept, the difference between heat and temperature. Temperature is a way we sort of measure heat, but it's indirect. To help understand this concept, I think it's useful to look at the units. Heat is a form of energy. Its units are joules or kilojoules. Temperature, however, is measured in degrees Fahrenheit or degrees Celsius or Kelvin. So it's not the same unit, and that tells us that they're different things. There is a way, however, to correlate temperature and heat, and that's with the equation Q equals Sm delta T. In this equation, m is the mass in grams, delta T is the change in temperature, and like any instance where we use the delta symbol, we are always saying final temperature minus initial temperature. And so the change in temperature can be either positive or negative, and that's important to note because that tells us the direction of the heat transfer. So we can't ignore the positive or negative signs here. It's important to always do that in the correct order, final minus initial. The S in this equation is specific heat capacity. Every substance, every object, everything has its own unique specific heat capacity, which is a measure of how that specific substance or object converts energy, heat, into a temperature change. The units of specific heat capacity are typically a gram per joule degrees Celsius or gram per joule Kelvin. Joule per gram Kelvin. So what we're looking at here is how much energy is required to raise the temperature of 1 gram of a substance by 1 degree Celsius. These values for pure substances can be looked up. You can find some in your textbook. You can also use Google. All right, let's look at a couple examples of some specific heat capacities. Styrofoam, which is what a lot of coffee cups and disposable cups are made out of. Disposable carry-out containers are made of styrofoam. Its specific heat capacity is 1.4 joules per gram degrees Celsius. Copper has a specific heat capacity of 0.435 joules per gram degrees Celsius. And water has a specific heat capacity of 4.18 joules per gram degrees Celsius. The metal here has the lowest specific heat capacity. What that tells us, the low specific heat capacity tells us that it only takes a little bit of energy to raise the temperature of the substance, and it only has to lose a little bit of energy to lower the temperature. This should match with something we already know about metals, right? We already know metals are good conductors of heat. So this low specific heat capacity matches with that substance's ability to conduct heat. Styrofoam, on the other hand, its specific heat capacity is about 3 times that of copper. It's a little bit more than that. And the high specific heat capacity is what makes styrofoam a fairly good insulator. It doesn't change temperature easily. It takes more energy to change its temperature. So it can prevent that heat from traveling from your hot coffee into your hand too easily. Water has a really, really high specific heat capacity. And so water is actually an excellent insulator. If you have a little bit of water on your hand and you touch a hot stove or something, that tiny bit of water in there will insulate your hand and prevent it from getting burnt. All right, so we can use the equation Q equals SM delta T to look at how heat corresponds to temperature changes, or how a temperature change corresponds to a gain or loss in heat. At this point in time, you should, I'm going to stop this video again, and you should try worksheet problems number 2, 3, and 4. Those are the problems on that chapter 5 in-class worksheet that's posted in Canvas.
Okay.